Hey, hello everyone. So today we are going to solve this LeetCode problem, which is validate binary search tree. So it's a pretty simple, straightforward. We just need to return true or false whether the input tree is a binary search tree. So definition of binary search tree is like all the left child of the root node should be smaller than the root node, and all the right should be greater. So this is a valid binary tree. I have to return true. This left is smaller than root, correct. Right is should be greater than, which is wrong. So this is not a valid binary tree. We have to return false. So how are we going to solve this problem? Is something we have to look closely. This um process is this that this binary search tree elements are such that if we do the in order traversal of this tree, which will be left, root, and the right. So left will be 1, 2, and 3. It will be 1, 5, then 3, then 4, then 6. So this is the in order traversal of the tree. And if we store this in a array list, so we would be having the incremental order of the values of the tree. And if we have that surety that we had the incremental order of values in the array list, and then we can just make sure that the all values are incrementing. There is no value such that the next index value is smaller than the previous index value. In that case, we will return false, else we will return true. So jumping to the solution, here we go. We will do the in order traversal, and we will just call a method. We'll create a new method which will we will pass this, and we will pass list. We need to define list, which will be array list. Okay, we define list of integer list to the new array list, and here we pass it, and now we have this void in order type recursive call method, which will have tree node, root, and we have list of integer list. Okay, so here we will iterate this tree, and we will convert it into the in order traversal and put it into the array list. So we have the base case that if this root is null, we just what do in base case is we return to break the recursion, and if it is not, we will just call this in order traversal with root dot left and list, and once this goes left 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 and it sees it's null, it will return, and now we will put this value in the list. So list dot add root dot well, and it will just add, and it will check right, it will return to the caller once the all statements are executed, which is left and right, and now it will return to the caller, and now the caller, which was eventually calling all the left part of the subtree, it will just come to this line, and it will add the root dot well, and now it will call the right part of this subtree, which will be in order root dot right and list. Okay, so now again the root dot right is called, and then this will again come back and see that the left is again called. It will go to left, and again it will see it is null, then it will return to this, and now this node will be added into the list, and then it will check the right part. There is nothing, then it will return to the caller, and then again it will check to the right part of the list. So this is how recursion works. It goes into nested call, and once the execution is terminated with this return statement, it just executes the remaining part which was not executed due to recursive call, and then it return it back to the caller, and then the caller was eventually at this location, and then it again tries to add it into the list with the root value, and again it calls to the right part of the list. So now we have the list, and we just need to iterate this list into I equal to 1, I is less than list dot size, and then I plus plus. And here you will see that if list dot get I, which is 1, is smaller than or equal to list dot get I minus 1. That's why we took the I with from 1, not 0. So we will return here false. It will break, it will return false, else it will return true. It is not breaking. So this is eventually it should work. And so the thing was that I thought of like this binary search tree eventually can be put into the array list with in-order traversal. So previously I was thinking of I was into like calling the left and then right and then doing some kind of return statement inside that recursive call and trying to return true and false based on that if the condition is failing. But this is a more proper use of array list data structure, and just trying to benefit from it, putting the values in the list and then iterating the list. And eventually, in all the cases of this tree problem, we usually traverse the tree with recursive process. So recursion is more or less visualizing the internal calls and then passing the control back to the caller and then executing the remaining part of the statements. And in order, we put the values in the middle before the left and the right. So this is how it was. Thank you for watching the solution. See you in the next problem.